Hello and welcome, everyone. It's a great honor to be with you today. We work at Scania, and here we are here to present our work on driving smart solutions and innovation in Scania. So let's go with the agenda. What do we have here? Starting with introduction, then human robot collaboration, computer vision and machine learning, industrial Internet of Things, voice gesture, control robots, and then conclusion. Let's start with introduction part. Our introduction part is divided into three sections. First is accelerate digital transformation. Starting with accelerate digital transformation, digital transformation is reshaping industries by disrupting existing businesses and operating models. Here we use technology and data to enable growth, optimize cost, and evolve to an insight driven organization. Going to the second part that says facilitate production logistics with Industry 4.0. Change is coming fast to our industry, and to drive the shift to cleaner, safer, and smart transport, we need to be able to innovate quickly. By combining Scania's core strength with new ways of working, we are rapidly developing the ideas and technologies that will shape tomorrow's transport system. Industry 4.0 is the application of technology to digitally transform how industrial companies operate. These technologies include the industrial IoT, automation and robotics, simulation, additive manufacturing, and analytics. These technologies need to be adapted to Scania's need and fit into the Scania production system. Our aim is to improve productivity, quality, and employee health. Going to the third point, where we predict future and act. This pyramid is a Maslow pyramid, which shows smart factories framework. The ultimate goal is to make faster and better decisions. How do we get there? We need to base these decisions on predictions of the future and on new insight. Where do these insights are coming from? An approach for predicting the future is to do real-time data gathering and analysis of data from the production line or any sort of machine. So once our processes are standardized and our technology is connected, we will be able to collect and analyze data that can help to predict the future and prescribe action. So this include our introduction part. Now going to the second part. Let's see. Here we see our vision and mission. So our vision is first choice arena for smart factory solutions. To achieve our mission comes into place where we adapt new technologies, evaluate as per Scania's need, demonstrate in Scania's environment, and then implement them. Before handing over to my colleague Sedorela, let's watch video one and see Scania's view on digitalization.
Sometimes it happens so fast, we don't even see it. Only when you stop and observe, you'll realize its full impact. We can travel faster than ever before, without even moving. We can communicate with millions of people, instantly. Today, glasses don't just improve our vision, they show us our imagination. What used to be manual, repetitive, and inefficient can now be automated. Trends can be spotted, analyzed, making future events predictable. We can make sustainable decisions for our planet based on real-time data. Businesses can expand their activities and develop into networks of information, providing whole new services. Digitalization is affecting everything around us. It integrates with every user experience. It's part of a seamless progression from then to now to tomorrow. At Scania, we see the opportunities. We are increasing our pace to take advantage of the changing digital landscape and all it can offer us.
Great. Thank you for watching with us. Now I am handing over it to my colleague Sidureva.
Thank you, Smriti. So I will talk about the human-robot collaboration. You can go to the next slide, please. One of the innovative and smart solution technologies that we use at Scania is human-robot collaboration, or HRC for short. HRC in the manufacturing context aim to realize a shared workspace where humans work side by side with robots in really close proximity. In human-robot collaborative manufacturing, robots are required to adapt to human behaviors by dynamically changing their pre-planned tasks. By applying HRC in our day-to-day work, we are able to achieve maximum flexibility by combining the best of human, like intelligence, and the best of robot, like endurance, strength, and accuracy. We are also able to achieve higher productivity due to reduced downtime and higher load capacity of the collaborating robot, and of course, better ergonomics for our workers. There are many technologies for enabling HRC, and of course, depends on the type of system as well. But in the demo, which I will show quite soon, we will focus on the collaboration of robot, or cobot for short. In this use case, we allow collisions between the robot and the humans, but in really low speed. There are 4 sensors integrated in the joints of the robots, which will detect the collision. And for more how it looks, the demo, let's play video 2.
The idea behind collaborative robotics is that both robots and humans can share the same workspace in a safe way, and thus combine the best qualities of both worlds, flexibility and intelligence of the human with strength, endurance and accuracy of the robot. Here we have a use case from the DE production unit in which today operators have to manually handle heavy gears, around 9 kilograms, and place them inside a pressing machine. The poor ergonomics of the station result in frequent injuries and the need to rotate operators often. The solution that we have proposed is to have a collaborative robot handling the gear for the operator by picking and placing it on the machine, while the operator focuses on the smaller pre-assembly tasks, which require more flexibility. Thanks to the safety functions of the cobot, even if the operator puts their limbs in the way of the robot, it will immediately stop after detecting a collision, preventing harm to the human and allowing collaboration in a safe way.
Moving to a new area, computer vision and machine learning. I'll represent 3 use cases how we have implemented computer vision and machine learning at Scania. The first use case is oil label verification. In each of the trucks, there is a part called cap corner, as you can see on the truck picture highlighted with red. And in the inner part of the cap corner, we used to stick labels, which gives us information about the oil types that will be used in this truck. There are 4 different oil types categorized in 4 colors, as you can see in the picture in the middle, and the engine oil is mentioned in 5 different languages. The operator who is standing at the station is not able to distinguish the language that will be used in this particular chassis. And by applying computer vision and machine learning in this use case, we are able to scan the labels and detect the language, the oil type, the color code, and the part number. Benefits of using computer vision and machine learning in this use case are saving times and second, lowering costs. The whole solution is built in open source technologies, except the camera which will be used to scan the label. Moving to the next use case, which is model badge. Model badge, it's a combination of a letter and numbers. The letter, at Scania, we use 6 model letters, which represent the model categorization, and the numbers represent the horsepower of the engine. The model badge can be different in different scenarios. For example, we have different truck models and different palette colors, and that would require a different model badge, of course. The badge can be metallic or matte type of material. By applying computer vision in this scenario, we are able to scan the badges, get product and components information, the model badge, and we compare with order information to be able to detect if this model badge is the right one for the truck. The benefits of applying computer vision and machine learning, of course, in this use case, it's first, by mounting the right model badge in the truck, we improve quality. And second, we save costs and time. Moving to the next use case, which is the front hatch. The front hatch is the front part of the truck. At this part of the process of building our trucks, we use a camera which will scan the front side of the truck, and we'll send these pictures that the camera clicks to our application. The application has a classification model that goes through the image and checks for these parts and where they're positioned in the truck. Thus, we are able to detect the lamps, which are marked with blue and yellow in the truck picture. We are able to detect if the mesh is open or closed, which is marked with red. And as well, we are able to detect the Scania logo, which is marked with a green circle. Applying computer vision and machine learning in this use case, we improve the quality gate by automating the gate operations. There will be no manual checks, and thereby we save repair and scrappage costs as well. Thank you for listening to me, and I hand over to my colleague Pavani.
Yes, thank you, Sedorella. So IIoT, Industrial Internet of Things, is another area that we are exploring currently within the Smart Factory. I believe many of you here have an idea of what IoT is and what we mean by industrial IoT, but just so we are all along the right lines, I would like to start by defining these terms. So to start with IoT, Internet of Things, it can be defined as a network of physical objects or things that we call here that are embedded with sensors, softwares, and other technologies for the purpose of collecting and exchanging data with other devices and equipments across the internet. So industrial IoT then can be defined as a process of acquiring and analyzing data from connected equipments, operational technologies, locations, helping us regulate and monitor industrial systems. With the application of IIoT, our aim is to make manufacturing more flexible, energy efficient, resource saving, and cost efficient. Two areas where we currently apply IoT, are in building something called sustainability dashboards and for achieving condition-based maintenance. With sustainability dashboards, we intend to visualize data gathered from different kinds of equipments in our industries, draw meaningful information from the data, and find ways on utilizing this information to act upon different sustainability aspects. So moving on to sustainability aspects. Well, the word sustainability is applicable today in a much broader spectrum. So to define it then for Scania and more specifically to the production and logistic division, we are visualizing it in this diagram, which you see here. So in this, in the middle, we see our focus area, which is to attain sustainable manufacturing process. And the circles on the outer side help us define different sectors, which help and influence in attaining sustainable manufacturing process. So moving from the top, then in the clockwise order, we have environmental impact, which relates to the carbon emissions in the manufacturing process. Then personal health can be related to, for example, like the noise sounds in certain PRUs, and economics such as lifting heavy equipments. Manufacturing costs then could be focusing on producing more with less cost and materials, which impact sustainability in general. And then operational safety, preventing several types of risk, both to the machines and to the operators, and with early reporting, for example. And waste management mainly could involve identifying the process which consume resources, but add very little to no value to our products. And the goal would be then to optimize such areas and to eliminate waste. Energy consumption relates more or less to the energy usages in our operations and general maintenance. Well, our steps in achieving this would start with collecting data from missions and sensors and visualizing the data and creating some real-time dashboards. Then exploring and enhancing various sustainability aspects. Well, each PRU has different needs, wants to improve in different sustainability aspects. So it's more like understanding the business and exploring ways to then achieve sustainability aspects. Then the next step would then be integrating Industry 4.0 standards, like moving towards edge intelligence and also predictive maintenance. In this diagram here, you see the connectivity plan we formed in the whole regard. So moving from the bottom, you see devices. We have several kinds of like vibration sensors, Raspberry Pis to which weigh scales are connected, and some sensors with like humidity, temperature and noise sensors, some energy and water meters, and some robots. And in our case, the ABB robots that we are using. So these devices are connected to networks. These are the networks that we have, like 5G, LAN, Wi-Fi, and LoRa networks that we are trying out with. They communicate using certain protocol. We are considering the three widely used protocols right now, so MQTT, TCP, and OPC-UA. And then we need some platform to gather the data, then a database to store it, maybe, and dashboards to view the data and draw some insights. So for this reason, we are using Scania's IoT platform, which is it's an in-house solution which Scania has developed using open source technologies and also AWS. Well, this is a glimpse of how the sustainability dashboard looks like. You see three graphs here. It's not required to go in details, but here you see a graph where we collected data from the weigh scale. Down you see a temperature and humidity sensors and the data from them, and also the sound information. But the point here is if you see it towards the right of the first graph, you see there are some maximum values, minimum values, and how the growth rate looks like. So the idea is to draw some insights basically. Moving on, yes, condition-based maintenance. Can go to the next slide maybe. Yes, the figure here pretty much explains what maintenance is and how we classify them. So if we consider maintenance in general, it can be classified as reactive and proactive. Reactive then is you react when a failure occurs. So it's often too late because there is some downtime, of course. In the proactive session, it can be classified again into preventive and predictive. So preventive, it's age-based. You just want to prevent a failure from occurring. So usually it's too early. It consumes a lot resources than it's actually needed. And then predictive is what we are achieving for. We want to analyze the condition of a machine before even performing some maintenance activities. So this is just right on time, saving us downtime and also the resources. Well, in this direction, then Scania's transmission assembly has these paint shops. It's important to maintain a steady ventilation system over there. And to achieve this, there are like heavy fans which act as exhaust systems sucking out air from the paint shops. It's often the case that there is minute amounts of paint that can remain on the fans, which were not cleaned up at the right time, result in line stops, causing an expense in millions of SEK for Scania per year. So it is important to clean up the fans based on their condition. And the way we aim to achieve this is by recording vibration levels of the fans and triggering maintenance work orders when the vibration reaches a certain threshold value. By enabling CBM in this use case, we aim to reduce line stops and optimize costs incurred in the process. With this, I'll hand it back to Sidorella. She'll be talking about voice and gesture control robots then.
Thank you, Bhavani. So in the technology area, the space between the physical and the digital world is brought together by the introduction of gesture concepts. For all the dangerous tasks, of course, we prefer using technology to complete these tasks rather than people. Nowadays, these robots can be controlled via voice and via gesture. This technology of gesture and voice recognition can be defined by the interaction between the computer and the body language of the human beings. This constructs the communication link between technology and mankind. We at Scania are working on several prototype applications which control the robot by hand gestures. In the next slide, we will see a demo how we have implemented two hand gestures controlling the robot. Let's play video 3.
To the demo. As you see, we have created an application which used to control the robot. On the left side of the screen, you see the person who is able to control the robot. On the right side, you see the camera which is showing us the robot which is getting controlled. Right now, we have created this prototype. Based upon two gestures, the robot is able to move to its left and right. Right now, we have configured it to two gestures, just the thumbs up and the victory sign. This one is scalable to different type of gestures. We could configure to any different kind of gestures also. Thank you.
Moving to our aims. Our business landscape is more disruptive than ever, with new technologies and business models emerging all the time. By using our modular approach and working with the latest technology trends like human robot collaboration, computer vision, AR, VR, robotics, and IoT, we are able to innovate rapidly, bringing tomorrow's automated, electrified, and connected transport solutions to today's transport. But along with urbanization and sustainability, digitalization is one of the main global trends that impacts society and the transport industry. At Scania, we apply digital technology to improve our core processes and create new business opportunities. This creates business value and, of course, increases the productivity in a safer and better work environment. With this slide, we conclude the presentation, and thank you very much for listening to us.
Thank you,
Thank
everyone.
you, everyone.
And let's go to our question answer sessions so we can have a discussion and we can take all the questions that you have. Thank you.
Thank you.
Thank you.